At the age of 25 years, Jason joined in a software company and opened an investment account that paid 6.5% interest, compounded quarterly. Now, in 35 years, Jason wants 75,000 in his savings account. How much should his initial investment be to reach his goal? And round your answer to the nearest $100. So in this scenario, we have Jason, who is 25 years old, and by the time he reaches 60, I think 25 plus 35, 60, he wants to have 75,000 in his savings account. Okay, so what is his initial investment? How much he has to deposit in a savings account which is paying him 6.5 interest? And what is the task for him? What is the thing he has to reach? The goal of saving $75,000 by the time he is 60 years old. Okay, now we have a formula for future value, right? It's like this. The future value FV is equal to present value times 1 plus I over n whole to the power of n times t. And in this, FV is the future value, t is the time in years, this little t, I is the rate of interest, and we have to write it in decimal form. N is the number of compounded periods per year. PV is the present value. So in this particular case, we have the future value. The future value is how much? 75,000. 75,000 here. Time is 35 years. It is 35 time in years. And rate of interest 6.5. 6.5%, that change it into decimal form is 6.5 divided by 100. This percent means per 100. So this gives me 6.5 over 100 is 0.065. And for number of compounded periods per year. So here it is compounded quarterly. So in 1 year, how many quarters are there? We know that 4 quarters will make one whole, right? 4 quarters is equal to $1. Likewise, in 1 year, we have 4 quarters. Like when it is compounded quarterly, the number of compounded periods are equal to 4. And PV is the present value. That is the question mark. We are looking for the present value. Okay. Having this in mind, let us go to this formula. Here, FV, actual future value equal to present value times all this we have. But we are looking for the present value because already we have the future value. Our task is to get 75,000, right? So what is the present value in order to reach that goal? Future value 75,000, and I'll divide it by 1 plus I was 0.065. We have I is 0.065, n equal to 4, and of course t is 35. I have to substitute those values. So I is 0.065 divide n, that is number of terms in 1 year, that is 4, and again n is 4. 4 times 35. Okay, so let us substitute these values. We have already substituted and I have to put them in calculator. Okay, so let me plug them in. I have a fraction, so I will do, I've got a fraction here. It is 75,000 on the top, numerator 75,000, and in the denominator I'll start with parentheses 1 plus, again a fraction, so 0.065, or you can just write 0.065, it is just the same thing, over 4. Come out of the fraction, close the parenthesis and go to the exponent, and then it is 4 times 35. So it is better to use the parenthesis. In this particular case, even without parenthesis you get the same, but I prefer this. 4 times 35, close, come out of that exponent, out of the fraction, hit enter. Yeah, this is your answer. $7,852.05 we have to invest in order to get 75,000 after 35 years. Okay, it is 7852.05. $7,852.05. That is the present value or your initial investment. And also in the question they asked us to round your answer nearest $100. So if you have to round it to the nearest $100, it is how much? 7,000 instead of 7,852. This 52 is more than $50, so I can just write down 7,900. 7900. $7,900. So on investing $7,900 at the rate of 6.5% compounded quarterly for 35 years will give us 75,000. So this answer here, it is $7,900 on investing for 35 years at the rate of 6.5% compounded quarterly results in a saving of $75,000. Okay, now this same problem we can also solve by using calculators app. I'll show it to you here. It is okay. We go to the apps here. In this applications apps, go to finance, and there you can see TVM solver, that is time value money solver. And let us plug in the values. We know that N is it is 4 times 35 because we are investing for 35 years compounded quarterly. So 4 times 35. The rate of interest was 6.5%. We don't have to change it into decimal form. Just whatever is the rate of interest, write it off. 6.5%. Present value we do not know. And these are payments or monthly payments or whatever is the regular payments. We don't pay this also. Only one time investment it is. So leave 0 there. Future value. You are looking for a future value of 75,000. So 75000. And here, how many payments you are making, I mean, how many times it is calculated. In fact, that is 4. That is quarterly. That's why 4 I have here. Automatically, the next number changes to 4. Then I'll make sure that it is highlighted on the end. Go to the present value. After entering all these values, I go to present value because we are trying to find what is the initial amount or the present value. So highlight that 0 and go to alpha. I hit that alpha here, that's A, and hit enter. See, it's giving me that result negative 7852.05, the same answer that we have. And we have a negative sign here indicating that we have to invest. That is the money that is going out of our account, from our bank, from our savings. You are putting it into that saving other deposit, so that there is a negative sign. The money we are spending initially to get that 75,000, right? I'll copy it here. So this one is much more easier if you can use the calculator directly. So that's what you have. The present value is 7,852. Round it to the nearest 100 to give you that $7,900. Right? This is another way of doing this same problem. So now I want you to try this one. Same Jason, if he's 20 years old and he wants to make 100,000 in this case, that is from 20 to in 40 years from now. By the time he reaches 60, he wants to have 100,000 in his savings account. And here the rate of interest is 5.5% and compounded quarterly. So try to find what is his initial investment. You use any of those two methods. Either use your calculator or this formula for finding the present value. Okay, please try. Thanks for watching.